So we're now going to solve for when the variable is up in the exponent. In order to do this, we have to review some of our exponent laws. So when I'm multiplying two exponents with the same bases, I need to add those exponents together. So if I have 2 to the 3 times by 2 to the 7, well, we keep the base of 2 and we add the 3 and the 7 together to get 2 to the power of 10. Similar idea when we are subtracting. If I have 7 to the power of 3 divided by 7, so 7 to the power of 3 minus, remember when nothing's written here, there's an invisible 1. So this simplifies down to 7 squared. This one is one of the most important ones. It's going to pop up a lot in this course. So this is just saying if I have anything to a negative exponent, if I reciprocate it, meaning I put it on the other side of the fraction line, it becomes a positive exponent. Same if I do it the other way around. If I have -2 down in the bottom and I reciprocate it, it comes up to the top and becomes positive. This is another rule that is used a lot when I have a power to a power. So if I have 2 to the power of 4 to the power of 3, this is 2 to the power of 4 times by 3, which equals 2 to the power of 12. Also, if I have two bases to a power, I can give that power to both of those bases. Then if we combine those last two rules, so now I have a power to a power, and I have two bases. So that outside power gets multiplied into those inside powers. So if I had 3 squared x to the 4 all to the power of 6, this is going to become 3 2 times by 6 x 4 times by 6 3 12 x 24. This is another one that is used a lot in this course, mostly with square roots. So the square root of a number is the same thing as that number written to the power of 1/2. So the 2 comes from our index. And remember, again, if nothing is written in a radical, that means there's an invisible 2 to tell you it's a square root. Okay. More common ones, absolutely anything to the power of 0 is 1. Even if I have smiley face to the power of 0, that equals 1. Anything to the power of 1 is itself, and 1 to the power of anything is just 1. So our three most common properties that are going to get used are our negative exponents, our power to a power, and our fractional exponents, especially with square roots. All right, so that's review. Now let's see what it looks like in grade 12. So for each of the following equations, write the terms with a common base. So a common base. What that means is we want to make the base of our exponent the same number. So 3 is already a small number. I really can't change that base any. So this left-hand side, we're not going to touch. So this is going to stay 3x plus 1. The right-hand side, what we want to do, what we're thinking, is we want to ask ourselves, can I write this as 3 to the power of something? So we know that 3 to the power of 2 is equal to 9. So instead of writing 9, we can rewrite this as 3 to the power of 2. So now that my bases are the same, we just have to focus on making the exponents the same. So now we're going to ignore our bases, and we're just going to try to make our exponents the same. So I just took the exponent from each side and set them equal to each other, because we can now ignore the bases. So now we're just going to do some algebra. I got to subtract 1 from both sides. That gets rid of the 1 on this side. So we get that x equals 2. All right. So again, looking at b here, we can see we have 2 to the power of 5x plus 1 equals the square root of 8. Again, this left-hand side is already as small as it can be. Nothing we can do to it, so we're going to just write it down. And we're again going to focus on this right-hand side. So first thing we have to do is we have to get rid of this square root. And if you remember, I said that anything to a square root is to the power of 1/2. So step 1, take that square root and turn it into an exponent. Okay. Again, we're not doing anything to this left-hand side. We're going to keep it the same. The right-hand side, now we're going to do some thinking. So again, we're looking for that common base. So I have to think to myself, how can I rewrite 8 as 2 to the power of something? Well, 2 squared is 4, and 4 times 2 is 8, so I can rewrite this as 2 cubed. So this is going to be 2 cubed, and we still have this exponent outside. So remember, all we did here was rewrite the 8 as 2 cubed. Everything else stayed the same. Okay. Again, haven't done anything to this left side. We're going to write it down again. Now on the right side, we have that other common rule I said was going to pop up, which is a power to a power. So we have to multiply these two things together. So that's going to give you 2. 3 times 1/2 is going to give you 3 halves. Now that we have the bases the same, we have to work with the exponents, make the exponents the same. So we're going to ignore our bases and say 5x plus 1 is equal to 3 halves. Now we're just back to simple algebra. Subtract 1 from both sides. That's going to give us 5x equals 1/2. We got to divide both sides by 5 to get x by itself. Of course, you can throw this into your calculator. This is going to give you x equals 0.1 or 1/10 if it's written as a fraction. All right. This side here, again, to the power of x, nothing we can do with that. But this right side here, again, we have to think 2 to the power of what equals 1. Well, this is when we remember the rule on the other page that says anything to the power of 0 is equal to 1. So I can rewrite this right side as 2 to the power of 0. So I have the bases the same. We can now ignore the bases, focus just on the exponents, which leaves us with x equals 0. No math needed there. All right. For our last one, now we have two things that we're going to have to change. So right away, as soon as you see a fraction, that's when we got to use that negative exponent rule. So we're going to change that fraction first. So 25x squared, we're just going to write down again. And we're going to rewrite this as 125 to the power of negative 1. So this is, again, just to get rid of that fraction and bring it up to the numerator. Okay, so 25 and 125, we have to change both of these. And we're going to change them both to a power of 5. So we're going to ask ourselves, 5 to the power of what is 25? Well, we can see that 5 squared is equal to 25. So again, all I did here was rewrite that 25 as 5 squared. We also need to think to ourselves, one 25, not just 25. Five to the power of what is equal to 125. And this one we get that it is 5 cubed. Again, we still have that negative 1 out on the outside. So again, all I did was take this 125 and write it as a common base. Right, now I have a power to a power, which means I need to multiply these together. So we're going to get 5 to the power of 2x. Again, I have a power to a power, which means I need to multiply these two things together. So I get 5 to the power of negative 3. Bases are finally the same. So we're going to ignore the bases and just set the exponents equal to each other. And some algebra says that I got to divide both sides by 2. And we get that x is equal to negative 3 halves. So our goal is always to get those common bases. So one step at a time, how can I get those common bases? Okay. So now we're going to look at what happens when I have an x on both sides. So I'm just going to rewrite the question over here. 3 to the power of 2x minus 1 is equal to 27x. So I can look, this one is already nice and simple, so we're going to keep it as 3 to the power of 2x minus 1. But now I have to think to myself, how can I rewrite 27 as 3 to the power of something? Well, 3 times 3 is 9, times 3 again is 27. So I can rewrite this as 3 cubed to the power of x. So again, the only thing I changed was I rewrote that 27 as 3 to the power of 3. Again, we're not going to touch this left side, it's going to stay the same. And our right side, I have a power to a power again. So we got to multiply that together. So 3 times x is 3x. Okay. Bases are the same. So we are going to ignore our bases and just set our exponents equal to each other. So when I have x's on both sides, so I have an x on this side and an x on this side, what we want to do is we want to move anything with an x to one side and anything without an x to the other side. So if I want to move this whole blue thing, this whole 2x, we can only move an x with us if we add or subtract. So because this is positive, we're going to subtract 2 x's from both sides. So that gets rid of the x on this side. So that just leaves us with negative 1. If I had 3 x's, I took 2 of those x's away. I'm just left with 1 x. So we get that x equals negative 1. So there's a second part here where they want us to verify our answer. So that's the nice thing about algebra, is you can always check your answer. So I like to do this with a little bit of a chart. I'm going to put the left side equation on one side, and I'm going to put the right side equation on the other side. And I'm just going to work with one side at a time. So what we're going to do is we're going to replace x in this equation with -1. So it's going to become 2 to the power of -1 minus 1. So if we throw this in our calculator is going to tell us that this is 1 over 27. All right, so I'm done with the left side. Now I'm going to go to the right side. So again, I'm going to replace that x with the -1 that we found. Well, negative exponent, in order to turn it positive, or if we put it into our calculator. So because our left-hand side is equal to our right-hand side, we know that our answer is correct. All right, at this point, you're going to pause the video and you're going to try these your turns. And then you're going to come back and see how you did. All right. So this first one has a step that you have to do first, and that's we want to get rid of this 2. So all of our other examples, we had the exponent beside itself. So let's make it look like all of our other examples. We're going to divide both sides by 2, which is going to cancel the 2 on this side. That's going to leave us with 2 to the power of x equals 1 over 64. I see that fraction again. As soon as we see a fraction, we know that we're going to need a negative exponent. So we don't have to write the brackets anymore. We can just say 4 to the power of 2x is equal to, this is now going to become 64 to the -1. All right, so now we got to figure out to ourselves, how can I rewrite 64 as 4 to the power of something? Well, 4 times 4 is 16, and 16 times 4 is 64. So I can rewrite this as 4 to the power of 2x equals, we know that 64 can be written as 4 cubed to the -1. Again, all I changed was rewriting that 64 as 4 to the power of 3. Again, we got that power to a power, so this is going to be 4 2x equals 4 to the -3. Bases are finally the same, so let's ignore the bases. 2x is equal to -3. Divide both sides by 2. X is equal to -3 halves. Next one, again, not much I can do with this left-hand side, so we're just going to write it down. Oh, sorry, this left-hand side, if I knew my left and my right at the moment. I see a square root here. As soon as I see a square root, we're going to get rid of that by changing it to the exponent of 1/2. All right, so then we have to ask ourselves, 5 to the power of what is 125? Well, 5 times 5 is 25, times 5 again is 125. So we're going to have 5x plus 2 is going to equal 125, can be rewritten as 5 cubed to the power of 1/2. So again, all I did was rewrite that 125. There's that power to a power again. Left-hand side here isn't going to change. Right-hand side is now going to become 5 to the power. 3 times 1/2 is 3 halves. Bases are the same. Let's ignore our bases and just set our exponents equal to each other. Subtract 2 from both sides, and we get that x is equal to -1/2. All right, last one here. Again, this time it's our right side that we're not going to change any, because it's already to a base of 3. So we have to ask ourselves, how can I rewrite 9 as 3 to the power of something? Well, 3 times 3 is 9, so I can rewrite 9 as 3 squared. 3 squared to the power of x minus 1. So again, I just took that 9 and rewrote it as 3 squared. Now I have a power to a power, so we have to multiply, and we have to firework this through. So this needs to be multiplied into both of these. We're going to end up with 2x minus 2. And of course, we didn't change this right side any, so it's going to be 3x minus 3. Now that my bases are the same, we can ignore our bases, and we're going to set our exponents equal to each other. So this is again one of the cases where I have numbers on both sides, and I have x's on both sides. So I don't like dealing with negatives, so what I'm going to do is I'm going to subtract the x from this side, and I'm going to subtract it over here. So 2 x's take away an x is going to leave me with an x minus 2 equals -3. Then I'm going to take this -2 and I'm going to add 2 to both sides. And we're going to say x equals -1. All right, so hopefully those all went well for you. I'm going to try the next example here. All right, so another your turn here. So pause the video, try it, come back and see how you did. All right, left side we're going to keep the same. Right side, we got to figure out, how do I rewrite 64 as 4 to the power of something? Well, 4 times 4 is 16, times 4 is 64. So we can rewrite 64 as 4 cubed to the power of 2x. So again, we just took that 64 and rewrote it. Left side is going to stay the same. Right side, I have a power to a power, so we're going to multiply those things together. Bases are the same, so we can now ignore our bases and set our exponents equal to each other. All right, so because this x on the right side is by itself, we're going to get the x over here on the left to join it. So we're going to minus an x from both sides. Get rid of the x on this side. So we get 5 equals 5x. Divide both sides by 5. We get that 1 is equal to x. And they want us to verify our solution. So one side is 4x to the power of 5. The other side is 64 2 to the power of x. So again, we're going to take this 1 and we're going to sub it into each side. So 4, 1 plus 5. Well, if we put that into our calculators, which equals 4,096. Right hand side again, we're going to just sub in 1 in for x. Put that into our calculator, get 4,096. So left hand side equals right hand side. So we know the solution is correct. All right. So solving exponential equations does not change whether it's exponential decay or exponential growth. The steps are still the same. But you can know whether or not you're getting the right answer, because if it's a decay and you end up with a bigger answer, then you know that something went wrong. Alright, so we're going to find some important information in this question here. A bacterial culture starts with 3,000 bacteria. After 3 hours, the estimated count is now 48,000. So obviously we can see we have exponential growth here because we're getting bigger over time. The exponential growth function that represents this is nt is equal to 3002 to the power of t over d, where d is the doubling period. So I always like to make myself a little cheat sheet on the side. In hours for the bacterial culture, it tells us nt is the number of bacteria and it says t is our time in hours. All right. So our question is asking us, what is the doubling period? So that tells me that what we are trying to solve for is this guy, which means I must know these other two things. Well, one of them is here. The number of bacteria we have is 48,000, and that happens after 3 hours. So now when I take my equation, nt is equal to 3002 t over d. Well, now I can replace. I know that nt should be 48,000. This part's going to stay the same. I know that t should be 3, and d is what we're solving for, so we don't know what it is. So again, 48,000 was our nt, 3 was our t. So now we're just going to solve this lovely equation. I have something outside my exponent, so we're going to start with dividing both sides by 3,000. That's going to cancel out this side here, and we're going to get 16 is equal to 2 to the 3 over d. All right, we got to get that common base. So I have to say 2 to the power of what? How can I rewrite 16 as 2 to the power of something? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. So this can be rewritten as 2 to the power of 4 is equal to 2 to the power of d over 3, or sorry, 3 over d. Bases are now the same, so we can ignore our bases and just set our exponents equal to each other. We can't solve for something that's in the denominator like this, so we're going to start with multiplying both sides by d. So 4 times by d is equal to 3. Divide both sides by 4, so we get d is equal to 3/4. Now, if this is a question on your diploma, doing all of this work will only get you 1 out of 2 marks. They need you to write what this means in context of the question. So you would say the doubling period for this bacterial culture is 3/4 of an hour or 45 minutes. So every 45 minutes, our bacterial culture doubles. And there you have it, our last example. So this lesson ended with you doing these your turns as homework. So we'll take them up in class tomorrow.